night. My name is Henry Morocho, a student of the Educational Police Technical University. The use of the Montecarlo method for the resolution of double integral is detailed below. The method used will be explained as will be a comparison with other existing methods. Introduction. Monte-Carlo integration is a technique for numerical integration using random numbers. It is a particular Monte-Carlo method that numerically computes a definite integral, while other algorithms usually evaluate the integrate at a regular grid. Monte-Carlo randomly chooses points at which the integrate is evaluated. This method is a particular used for higher dimensional integrals. There are different methods to perform Monte-Carlo integration, such as uniform sampling, straight sampling, important sampling, sequential Monte Carlo, and mean-file particle methods. This is an illustration of Monte Carlo integration. This example to domain D is the inner circle and domain E is the square. Because the square's area 4 can be easily calculated for a circle P or 1 2 can be estimated by the ratio 0.8. The point inside the circle 14 to the total numbers 0.15, yielding an approximate for the circle's area 4.08 equals 3.2. Below they present two videos of the network, which better explain the method Monte Carlo and the application for the resolution or approximation of an integral. This video is uploaded to YouTube. This is a review for your interest. Program description. In this project, these use different algorithms for the integrate a double integral. Approximate the integral using a Riemann sum function. The function to be integrated a and b are the lower and upper integration limits respectively. N is the number of rectangles used approximate. Riemann sum. For the Riemann summation method, for the approximate the area under curves, right or left methods make the approximate using the right and left endpoints with each subinterval respectively. Maximum and minimum methods make the approximate using the largest and the smallest endpoint values for each subinterval respectively. The values of the sums converge as the subintervals half from top left or bottom right. In the mathematics, a Riemann sum is a certain kind of approximate of an integral by a finite sum. It is named after 19th century German mathematician Benjamin Riemann. One very common application is approximate the area of function or lines on a graph, but also the length of curves and other approximations. The sum is calculated by diving the region in the shapes, rectangles, trapezoids, parabolas, or cubics. That together from the region is a similar region when we measure by calculate the area for each of these shapes. Adding the small areas together, this approach can be used as a numerical approximate for the infinite integral event. If the fundamental theorem calculates does not make easy find to closed form solution, because the region filled with the small shapes is usually not exactly the same shapes as the region being measures. This error can be reduced by diving up the region more finely, using smaller and smaller shapes, and the shapes get smaller and smaller. The sum approach Riemann integral. This is the estimate integral result of the error that use the Riemann sum method. Next, we'll try different sample density uniform distribution in a Gaussian. Uniform distribution. This is applied a continuous distribution. The problem theory and statics. The continuous uniform distribution or rectangular distribution is a family of symmetric probability distributions such that are each member of the family. All intervals of the same length on the distribution support are equally probable. This support is defined by the two parameters A and B, which are the minimum and maximum values. The support is defined by two. The distribution is often abbreviated U as AB. This is a maximum entropy probability distribution for a random variable x under the constraint that is contained in the distribution. This is example, the resolution, the integral. Next, this is explain the resolution of double integral with the Montecarlo MC method. This project is in the tool Jupyter Notebook. This explains the Monte-Carlo umbrella term for a whole range of different methods, all will involve random sampling. One big advantage of method MC is their accuracy independence dimensionally of the space to be sampled, which represents a big improvement over the Riemann sum approach. MC methods are a huge subject in themselves, and the word variably going to stretch the surface here. This is explained in the form. The MC method makes use of the link between sample theory and integration. If the draw n independent random sample xe for a continuous random variable in distribution p the x, the law of larger numbers says the average of sample values converges to the expected value of distribution as n tends lower infinity. For continuous random variables, the expected value a in x can also express as an integral. This is explained. Furthermore, the exact value of function g in x that x a probability density function p in x can be written thus. Next, importance sampling. The first sampling strategy we will consider is called importance sampling. Note that although this approach provides a method for evaluating integrals, which is one of the aims listed at the start, it does not allow to say much shape, posterior distribution, reflection change related techniques can be done. Importance sampling direct extension above concerning. The example, the exercise is integral in two dimensions, x and y. This is a function Riemann. The results obtained the use can be method. This is approach uniform distribution in the Gaussian. The function, this is the result, probability density. Looking at the image, both is declared when you draw something from uniform distribution. Values toward the margin the plot will be overrepresented compared to target distribution, which towards the middle of the range will be underrepresented. To account for the calculated weight, which we will adjust importance for each page or sample. Importance sampling. Try a different variant sample size. Next, plot results based on different sample sizes and sampler densities. Next is example. This is part of the integral. Resolution of the integral Monte-Carlo MC method. This is a program in Python, the method integration Monte-Carlo MC. This is a function declaration function. This is the use for the code. This way the function or method use the class Monte-Carlo for resolution the integral double. This method is for graphic. The main is the parameters for the class Monte-Carlo, the estimate of the error, number of iterations, precision grade of integral. This is calculate the binomial and the standard deviation. This is a percent number of available monsters. This is a represents graphic in 2D and 3D. This is our result. The use method Monte-Carlo and the row approach. This is a function. Thanks. This is my code, the project.